Hi, my name is Wastl. I'm the creator of Advent of Code. Why don't we begin here? Before we get started, quick show of hands. How many people have actually heard of Advent of Code before? We're like, actually, oh good, okay, that's important. That's probably a prerequisite for parts of this talk. How many people have solved at least one puzzle, though? All right, still like the same number of hands. How many people have completed an entire year? How many people have completed all of the years? One. There's only a couple hundred people in the world that have completed all of the years. Well done. All right. Well, yeah, so my name is Eric Wastl, and this is Advent of Code Behind the Scenes. Who let this guy on stage anyway? So I used to make large-scale web applications for ISPs, but now I work on infrastructure for an auction system. Both of these companies are in Buffalo, where I live. These are my day jobs. On the side, I also run programming challenges like Advent of Code. I also make tools for games. These are EVE Online, League of Legends, Minecraft, and World of Warcraft in that order. I also make fun of programming languages. If you've ever been to these websites, this is also me just being snarky instead of teaching people stuff. And I also make lots of other random things. But we're not here to talk about those. We're here to talk about Advent of Code. So what's Advent of Code? Let's rewind a little. Here's a question. What if you are here? Sorry, let me zoom in a little bit. Hang on. There it is, sorry. What if you are here at this tiny cafe in Salem, Massachusetts, hanging out because you're there with some friends that like Halloween and they wanted to come and see the place where Halloween is celebrated, whatever. And all you have is a pen, a few napkins, a few weeks until Christmas, a random memory of advent calendars, and a passion for programming puzzles and helping people learn to become better programmers. The answer? Advent of Code, which is a combination of advent calendars and programming puzzles. So, advent calendars? Yeah, so depending on how you celebrate Christmas or whether you celebrate Christmas, you may have seen these. An advent calendar is typically a little like cardboard box or sometimes something you can hang stuff on or whatever, that every day for the season of Advent, which varies by how you define it, but in Advent of Code we use the first 25 days, you basically count down until Christmas, opening up a little door and getting out a little chocolate or a toy or whatever, a programming puzzle maybe, very traditional gift in Advent calendars. This one is mine. When I was growing up, you take out the little ornaments and you just hang them on the trees. You don't really get anything, but it's reusable. It's nice, right? At Advent of Code, they look like this, where every line is a door that you can click on and you can open it up and get a puzzle. Or sometimes they look like this, or sometimes they look like this. So where's the programming puzzles in here? Well, they're down here. Every day, one of these lines lights up and you can click on it. And when you do, you get a puzzle. And the puzzle has some kind of goofy story about Santa and elves and rescuing Christmas and all of these things that go on. And eventually you get down to the part where it actually explains to you what you're programming today. And in this one, this is the first one of last year, it says, add up all the numbers in the file. Okay, well that's all right, that's fine. Where's the file? Okay, there it is. Get your input. The puzzle input's the same for part 1 and part 2. Spoilers. And then you finally get the answer, and you add them all up, and you put them in this box, and you hit submit, and you get a gold star. And then you move on to part 2, which takes the same input but makes you do something different with it. And hopefully something that forces you to rethink how you approached the problem, or maybe it was something that tried to verify that you were on the right track for solving the puzzle or something. I'll get into how I designed that stuff in a second. But part 2 of this one was you have to keep going through the list, adding up the numbers over and over and over because there's pluses and minuses, and it asks what number do you reach, like what total do you reach twice in a row, or not twice in a row, twice at all, ever. And it takes about 100 loops, and you go through and you finally get a second value, and once you fill in that one, you get 2 stars, and then the calendar starts to do something, and as you answer more puzzles, the calendar fills up more and more, until eventually you have a full calendar, and there's a coffee mug floating in space for reasons that are spoilers, and you'll have to solve the puzzle to find out. So it's 2015, and you just built a bunch of programming puzzles. Where should we host this thing? Programming puzzles probably won't be that popular. Let's do some capacity planning. Many of you probably have your engineers have to do some capacity planning at your job of some sort. You have to figure out how big the server should be to host stuff, right? Programming puzzles probably won't be that popular. But I have a few friends that might like it. Okay. And I've released silly programming things like this before, so I have a rough idea. You know, they might have a few friends that like it. 50 people? 50 people seems like a pretty safe guess. Friends and friends of friends, and it's programming puzzles, and you know, it's kind of a niche thing. But I learned at work that we should have good margins on our estimates. 70. Wide margin, right? All right, good. So a small personal web server will cover it just fine. There'll be no issues. I've got a server that's running someplace that will be able to handle the traffic. Point the domain name at it, host it there, it'll be easy. So it's November 30th, 2015 now. It's almost December 1st. It's time to publicize the site to the world and tell everybody to go to it and do whatever there is. Nobody's heard of this thing before, so I release my secret project, and it gets 27 retweets, which is perfect. That's within margins. Good. Okay, so capacity planning is fine. 27 retweets is fine. So here's a graph of the number of users that have signed up, starting when I announced it and opened the site, up until midnight, before the first puzzle unlocks. So there's 70 users, there's 81 users. Looks like we're well within estimate. That seems completely reasonable. Nothing bad will happen. Foreshadowing. Then the puzzle unlocked. And the graph does this. If you're not a technical career path, you may not know the technical term for this shape of a graph, which is, oh no. No. 12 hours later, there's my estimate, and the graph is just gone. It's just left. Let me zoom out a little bit. That's what it did. This is a bad shape for your graph to have. That's my estimate. That's 4,000 people. So, okay, I mean, capacity planning, right? We should consider how this is going so far. Take a step back. We estimated 70 people. We have 4,000, 12 hours into the event. It's a 25-day long event. That's not great. We're off by 5,600%. The small server is very sad. That's also the technical term for that. So you're bad at traffic estimation. Now what? So you've got this project that you didn't expect to be popular. This part's interactive, by the way. You have this project that you were expecting to be popular, and or that you weren't expecting to be popular, and it's just like small server running, you know, can't keep up with this traffic. The CPU levels are high, the memory usage is high, the disk I/O is high. Like, this is not going to keep up with this kind of growth curve. Now what? What do you do? Scaling what? It's one server. I don't have time to like build out a infrastructure somewhere. What do you do? Caching, maybe, except that every user has different content, different website, different internet. Did anybody say turn off the Minecraft server? Because that got way more capacity. Turns out that was the problem. At least part of the problem, because then the numbers kept growing and we had to do item 2, which is don't create a new process to handle every single request. Now hang on, what? Why? What is that? So CGI is kind of an old way to run things, but it's an easy way to prototype and build stuff. The way CGI works is you have a process, a typical Unix POSIX process. Typical processes have some kind of input, environment variables and standard in and that sort of stuff. They produce some kind of an output, a standard output, standard error. They in CGI, they are mapped to the headers in the request body coming in and the HTTP response and the logs going out. Pretty simple, easy to build stuff, easy to prototype stuff. Sometimes it might also talk to database files, API calls, things like that. But in general, when you're running a process in CGI, you have these kinds of inputs and outputs. And the problem is that while this is simple, this happens for every request you get. Which for 70 users is no problem, but for 4,000 users is very, very, very bad. When you get rid of that overhead by switching to emergency switch fast CGI panic mode, that was a horrifying day, it was much, much better. Fast CGI basically just mimics CGI but doesn't actually restart the process. It just keeps feeding it new inputs, and it barely handled it, but it did work. So 24 hours since unlock, the graph continues to look like this. That's my estimate. There's 9,000 people. So hold on a second. Where did all these people come from? Like, what's going on? Does anybody see the flaw in my reasoning? You may notice that this part I've highlighted is recursive. So this happened. Because social media is a weird place, and all of a sudden, everyone's friends were talking about it to their friends who were talking about it to their friends. This scrolls for a while. 48 hours after unlock, there's my estimate. That's 15,000 people. Let's fast forward a little bit. That's what the curve looked like at the end of year one. That's 52,000 people by the end of the first year, at which point people were using the site significantly less, and we did the actually correct capacity planning thing, which was to just move to AWS completely. Which has been serving us very well, because if more people go to the site, I can just click buy more servers until it stops breaking. Like a real business, right? Today we have 250,000 people, and it's still growing, which is fine because I can click buy more servers a couple more times. So why do people do Advent of Code? What's going on? A lot of people do them as practice problems. Either because they want to get better at a language that they've already been using, or there's some new language that they want to learn because it sounds fun, or because their job is requiring them to do some new project that has something like that. But to basically hone their skills on some kind of a language, or on problem solving, or on like algorithm design or data structures, or in general, right? That sort of stuff. But a lot of people also do it for interview preparation. There are a lot of companies that ask questions like Advent of Code puzzles in their interviews. And people will use Advent of Code for interview prep for that. I'll talk more on that in a bit, actually. There are some companies that do it as sort of a company corporate training sort of event thing, where during December they'll take a Friday, and anybody that wants to can go into a conference room and work together on these puzzles together, like Friday afternoon, instead of doing their normal job, because that company is good and thinks that learning is fun, which it is. Some people do it as a speed contest. I don't recommend this, but there is a leaderboard that tells you if you were fast. You weren't. Don't try. It's not a good idea. The people that get on the leaderboard are competitive programmers that do this year-round, and just like this is just all they do all the time. They know all of the tricks. They take all of the shortcuts. They do not build good maintainable code. Like, they're hacking together the first thing that'll work. They already have an implementation of highly optimized A* using a priority heap on their like ready, open enough in a window. Like, you're not going to go faster than that. It's not a good idea, and it's not fun. I don't recommend it. But a lot of people enjoy doing that. More power to them. And also challenging their friends. So if you've gone to the subreddit, which is a very encouraging group, it's kind of neat. I'll talk more about the community in a bit. A lot of people there will say, hey, this puzzle was neat, but I can think of a way to make it significantly harder. Can anybody solve my much, much harder version? And some people can, and it's super fun. And some people are like, what? And then they read the solutions. What? That's fun too. And then hopefully somebody comes along and explains it, and everybody learns something new that day. So who are all these people that are doing Advent of Code? Everybody, primarily English-speaking countries, obviously, but like I get traffic from most countries, like significant traffic. Here's the United States. New York is where I live, Buffalo. And I'm blaming California because when the puzzles unlock at midnight in New York, it's only 9 p.m. in California, which means that they can actually still be awake to do them. Here's Europe, where you guys have to wake up at 5 a.m. and 6 a.m., and I'm only a little sorry. Some people use it as part of their morning routine, though. This is somebody literally doing Advent of Code while in the shower, getting ready for work. And I get a lot of comments about this, both positive and negative. I get some people saying, waking up at 5 a.m. every day is not easy. There's no way that I can get up at that time. I just get up at my normal time, and then I do it during my lunch or whatever, And then there's a whole other group of people that say something like, I have never been able to wake up early as reliably as I can December 1st through 25th because of these puzzles. Like, great, that's cool. There are a bunch of people actually, even in Europe, who stream the moment it comes out at 5 or 6 a.m., like still in their pajamas, like well done, like half awake, like barely have their coffee. And they're like, what is this problem? Oh, it's all right. Hang on, let me just drink 17 coffees and I'll do right on stream. Like, cool. Who are all these people? They're programmers. They're programmers of every type. Here's a bunch of languages of all different disciplines and styles. If you look just on GitHub for these, you can see 23,000 repositories of any language you can imagine, including some repositories that have 25 different languages in them, which is alarming and a little weird, but super cool, right? Like, go for it. Here's somebody that solved a bunch of them one year using an FPGA. An FPGA is a circuit that you can tell to be any circuit you want, and so it's basically solving it in like configurable hardware. I don't know exactly how it works, but it's super, super cool. And they solved a bunch of them by building a circuit and then configuring their FPGA to be that circuit, and then it would solve the puzzle. And it's really neat. You get companies that do it. Most big companies have at least a small group somewhere that's doing it. There's London Facebook posting all of their visualizations on the glass overlooking the stairs, just so the people could see all their cool stuff. Here's a university, I think in Poland, that every day would translate the puzzles so that during that day their students could read in their native language and then solve them, and then they would all post their solutions on this giant column in their student union so that people could see all the stuff that they were working on and work together on things. That's super neat. Non-programmers do it a lot. Here's somebody doing, I think this is day 1 of 2016, in graph paper, which was working out pretty well for this person until they discovered that one of the like turn left, right, go this far, turn left, right, go this far distances was like 600. And so they're getting out some more graph paper so they can go out the rest of it. They eventually got the right answer, though. This is that actually, they just took them longer than the person here on the couch who already is finished. But you know, here's a guy on Reddit who is also a friend of mine, actually, who does every year in Excel. He finishes about half of them, which is astounding because he's using Excel. Not Visual Basic, mind you, literally just cells and equations and like that's it, and he solves them, and this is incredible. If you ever see him posting his solutions, just open up the spreadsheet, count the number of seconds it takes for Excel to actually load the spreadsheet, and then try to figure out what he's doing because it's madness. Also on this note, actually, I was just talking to a group where there's a company where they're trying to get their managers to get more into thinking about puzzle solving, and they're going to use Advent of Code to do it, but most of the managers aren't programmers. So they're telling the managers, like, hey, just use Excel. You can do it that way. And there's a couple programmers that are going to be doing it in Excel with them to try to show them, like, look, if we can do it in Excel, so can you. Here's somebody using Google Sheets also. If you don't want to pay Microsoft, you can pay Google instead. Just solve puzzles that way. So this is 2018 day 6 or 7, I think. It's the one where you have to have the parts for the sleigh, and you have to figure out what order to assemble the parts in order to figure out how to build the sleigh, right? And you're supposed to write a program that figures out that it's a directed graph and tries to find a topological sort and there's all these fancy words for the things you have to do, but you basically have to figure out what order to do the parts in, right? This person just took all of the data from the puzzle, plugged it into a Gantt chart system, and asked it what the answer was. And that worked completely fine. That's great. Here's somebody that solved one of them in Minecraft. The stone blocks here are the data from the puzzle, and it's actually going through and reading the data and doing the calculations in Minecraft. It's not a good idea, but you can do it. So let's talk about puzzle design a little bit. So I build a lot of puzzles. When I'm ready for this year, which I am almost, I will have designed 250 puzzles, which is a lot of puzzles. And there are some things that I need to do as part of the Advent of Code format when I'm making a puzzle, but there are some things that I've taken away from it and just used as good ideas in general when designing a puzzle or anything that's even puzzle-shaped. A lot of corporate trainings or even just like complicated documentation with examples of like how to use a feature in some library you're maintaining or something like that all have kind of this similar format of like, here's how to explain like how this thing works, how to use it, here's some examples of how it functions, here's places it might go wrong, and explaining that sort of stuff has to happen regardless of whether you're doing a corporate training or an open source library or making a puzzle on the internet for 50 of your friends, right? So some of the things are avoiding ambiguity, which sounds obvious, but it's a little bit more difficult, especially because I've got users from all around the world, many of whom English isn't their first language. So looking out for things like confusing sentence structure or multiple interpretations of a sentence, it's really easy, especially in English, because English is awful, to build a sentence that just like doesn't make any sense, or that could be like read in 2 different ways, or you can't tell what word is supposed to relate, and paying attention to that, because I know what the puzzle is supposed to say, but you don't, and so when I read the sentence, I always read it the right way because I wrote it, but if you read it, you might read it a different way, which is why you need to have other people test the puzzle. That's really important. Or to read the sentence that you wrote because you have assumptions that they don't, or just multiple interpretations of what you've written. If something could mean, like if a word could mean 2 different things, but you don't realize it because you're only thinking about the one definition. avoiding expectations of outside information. This is a good one also for interview problems. If you design interview problems, expectations of outside information can make it very, very hard for somebody to solve your problem. If you assume that the user has taken a data structures course and understands what a hash is, or understands what a red-black tree is, or understands what a priority heap is, or whatever, right? Or if they may not have taken any CS course at all, depending on the material. A lot of people that do Advent of Code aren't programmers. They want to be programmers. And so they're saying, all right, I'm going to learn this language my friend gave me in this IDE my friend installed, and I'm going to start typing things into this box until I get the answer according to this website. That's a common use case. And it's not a, it's not a common group of users, but they do exist, and making sure that they're also covered is important, because it's an important thing in helping people learn to program, right? So they may not have taken a CS course at all. They may not know what a conditional is. They may not know what it means to loop over something. They may not know what an index is, right? And so trying to either use those words and define them on the spot, or use a different word that means the same thing, like maybe instead of index you say position or something like that, or at the very least linking to an article someplace that explains it if you think the number of users that might not know it is very low or something, right? But avoiding the expectations of outside information. Or another one that's really tricky, the user might not have the same domain knowledge as you. So if you're asking about sleigh building and you actually use words that are part of like the industry of building sleighs, which I am not, so I didn't, but like you could imagine like if, attach this thing to this thing in this slot, whatever, like you can't, none of those words mean anything to anybody unless you're in that industry. So if you're in an industry that does some particular thing, like you're building cars or something, and your interview questions assume the listener understands what some random word for a car part is that they definitely don't, but you forget that because you're in the industry already, it's really easy to build a problem that literally no one can answer but you, because you use terminology that doesn't exist. It's also really common in the space industry. Everything in the space industry is exactly 3-letter acronym long, every single term for anything. It's extremely confusing. Avoid requiring the user to make assumptions. So I used to repeat myself a lot less in early puzzles because this wasn't really obvious to me yet, but as I built more and more puzzles, it occurred to me that for every sentence, there is a user that skipped only that sentence, just because they were skimming or glossing over or whatever, they jumped down a line for whatever reason, and they didn't realize that that sentence was important. So if something is critical, try to either state it more than once in a different way, or imply that it's true someplace else in the documents, that they say, wait, I don't remember reading this, let me go back and find it, or but tie everything together so that they can't have like one bit of information that they missed and don't realize they missed. And also having other people actually look at and test the puzzle. I have a team of beta testers. They're excellent. They read through the puzzle, they tell me I'm dumb all the time, and then I go and fix the problems until they stop telling me I'm dumb. And then everybody online, still finds problems with it. But at least we've caught most of the big ones, right? But having other people look at it so that the assumptions that I'm making aren't intrinsic to the puzzle, and all of the information that you need to solve it is still in there, turns out really important. So how do you make an Advent of Code puzzle? So once you've done all of that, the properties of an Advent of Code puzzle includes some additional constraints. One of them is there has to be an exactly one correct answer for every input. The way the website works is you get an input file, and there are lots and lots of input files, but every single one of them has exactly one correct answer, and all of the answers are different, and none of the answers are too close to each other, because that might mean that an off by one error means that you're getting somebody else's answer, and that's not good. So there's all of these constraints around that. It has to work in any language, or at least any reasonable language, so anything but PHP. And you are just getting an answer from this user. You're not running their code, which means that you can't measure the performance of their code, because I don't want to host the infrastructure to do that. I don't want to put up with the security risks of doing that, right? There are some websites that will run your, so I'm told. I try to avoid other puzzle sites just in case, but I'm told that there are sites that you give them your code instead of your answer, and they run your code, and then if it was too slow, they tell you it was too slow, and I can't really do that. So instead I have to design puzzles where if you do it with an algorithm that's too slow, it would take 3 years to solve on any computer. And if you do it with the algorithm that I intended, at least for optimization problems, right? If you do it with the algorithm that was intended, you get it in about 5 seconds, or less if you're using a compiled language. And that way I can still do like timing type stuff. And it's just, if you don't do it the way that was intended, if it's a problem that's looking for you to, you just never get the answer, and it doesn't matter. Lots of inputs, I talked about that. 2 parts per puzzle. So originally, Excuse me. Originally, I had 2 parts per puzzle because I thought it would just be an easy way for me to add on like a little fun extra at the end of all of the main puzzles. So all of the part 1s were going to be like the main puzzles, and then all the part 2s were going to be like, oh yeah, what if you did this? Oh, that was cool, okay. I just basically double my content almost for free. And it never went that way at all. What it ended up being was, as I started to build puzzles that were even a little complicated, it was convenient to be able to use part 1 to just make sure that the user was on the right track. So instead of having part 1 be the puzzle, part 2 is the puzzle, and part 1 just says, like, did you read the input correctly? Like, did you get all the numbers in there? Did you copy and paste it right, or whatever you're doing? Maybe you have to like run a checksum over the values, or maybe you have to start implementing part of what you're going to need in part 2. Just, are you on the right track? Because doing a jump to a finished puzzle all in one go means that you're not really sure where your bug is if you do have a bug, and you either have to read through the instructions completely again and try to find where you misunderstood or mismatched something, or just, you know, you have a typo someplace and it could be anywhere. Whereas if it's a checkpoint, you know that the first half is right, and you don't have to debug that part, hopefully, again, and then you just only have to check, you know, half of your remaining code. So there's that. But the other thing that I'll try to do is for puzzles where it makes sense and the first question isn't that much of a jump, ask that question, and then for part 2, swipe the requirements out from under you, and you either built it in a way that was planning for me to do that, or you didn't and spent another 2 hours reworking your code, which is a good way to simulate what really happens in the real world, where a group of engineers all of a sudden get information from their product manager that says, you know, hey, the user really wants this button to be configurable and what color it is, and you're like, oh, we didn't account for that. Hang on a second, we had to build a configuration system now. Oh no, or whatever, you know. Also, variety. Variety is really important for a lot of reasons. A lot of people have different backgrounds. A lot of people have different interests. A lot of people have different skill levels in different areas. So making sure that every puzzle is different, or at least that there aren't a bunch of puzzles in the row that are all like the same, like a day after day after day after day, right? Like keeping things interesting is important to make sure that people don't burn out, or that they get stuck a bunch of times in a row, hopefully. And you can't control it for everybody because everybody has different sets of skills. But setting it up so that it stays interesting, or at least teaches everybody something different every day, is really, really important. And also difficulty calibration. Sometimes, if there's an early puzzle that seems hard or it seems weird, sometimes it's just a simpler version of a puzzle that I'm going to do later, and I want to make sure that everybody's done the simpler version first, that they have some of the prerequisites that I'm about to assume they have later on when they need that stuff. Examples of that in the past were like some of the pathfinding problems in, I think, 2016, where there were some earlier puzzles that were just like, you know, just find the shortest path from here to here. Okay, like toss breadth first search and you're done. And then the later problems are like, all right, find some pathfinding, but you can't use breadth first search anymore because of some constraints in the problem, whatever. And you're like, okay, well, now what do, you know, you figure it out like that. But just introducing concepts. Whether it's a weekday versus a weekend, people tend to have more time to do puzzles on the weekends, like on Friday night and Saturday night into the weekend. So making the more involved problems, not necessarily harder, but just the ones that have more stuff to figure out, aiming to put those on weekends where it's possible, but it isn't always. Variety for difficulty, we talked about that a little bit, but it's still really important because everybody is good at different things. You might be really good at regular expressions, but you really might hate, you know, string comparisons or whatever, I don't know. And making sure that all the puzzles require some different set of skills helps with difficulty because it prevents burnout. Progression throughout the month, yeah, they gradually get harder, they build on each other or whatever, so scaling that and making sure that it goes well, but also having random puzzles that aren't in that difficulty. Maybe you have an early hard puzzle to prevent people that are really waiting for some juicier puzzles, preventing them from having to wait until the end of the month. Like, okay, here's a more interesting one, but it's still one that's acceptable to intermediate beginner programmers if they want to work at it a little. And maybe there's an easier puzzle late in the month because, you know, you've been working at hard puzzles day after day after day. Oh, it's an easy one. This took me, you know, 20 minutes. I'm going to go back to, you know, preparing for Christmas or whatever you're doing. And also thinking about interpreted versus compiled languages. I talked about this a little bit with like timing calibration. But the goal is that regardless of the language you're using, if you come up with the solution that I was hoping you would come up with, it should take at most 15 seconds to run on pretty old hardware. Like, accessible to anybody regardless of the computer they have. You don't need a state-of-the-art Mac or whatever to solve the problem efficiently. But for the problems where it's an optimization problem, and I actually am expecting you to implement, optimized A star on some subset of the state space, and you have to figure out how to prune that correctly and all of these things, it's important to design the puzzle in a way where even if they're using a compiled language and the speed up they get from that, it's not enough to have a less optimal solution to get the answer in a reasonable amount of time. Like, it still needs to be a large enough gap that the amount that you save from having a compiled language is not enough to get you the answer soon enough. And that takes a while to build too. But yeah, there's a lot of things that go into that. So how do you actually make one of these? The first step is inspiration. I get inspiration from a lot of places. I get inspiration from just like random problems that I'm working on at work, or random things that I'm building off to the side, or side projects that I'm working on, or an open source project that had to build a function that just does kind of an interesting thing, or just random things I see in the real world, like, oh, that's a neat, giant mobile structure, or that's a cool sculpture, or there's a bunch of tiles that are laid out in a neat way, random stuff like that. But take inspiration from something. Try to figure out how you could make a question around it, make a problem around it, and then research it. Make sure that it's not just like something everybody has in a standard library. Make sure that it's actually something that's interesting enough that people will care to work on it. Try to see how studied it's been already. If it has been, maybe tweak it a little bit to at least get it out of OEIS, like it was that one time, the Online Encyclopedia of Integer Sequences, where one of the answers was just in there. Designing the puzzle, so figuring out like, okay, now that we are pretty sure it's good, let's actually construct like a prototype or try to build something out that just, wait until it feels like it's a decent puzzle. Build a script that generates inputs. Literally just run it and it spits out, here's an input file. It might take, a couple hours to do, but like, here's a good input file. Solve it, just like you'll have to, because I need to get the answers the same as you. Generate a whole bunch of inputs using that process. Generate and solve all the puzzles, and then write a story around it. And the story usually happens last. Usually the variable names, for example, in the input generator and the solvers are not the same nouns that the story uses. The variable names in my stuff, because I haven't really even thought about the puzzle yet, because I'm going to change it 100 times before I actually write a story about it. So the scripts are all like, grid and XY and whatever, just like generic terms. When I actually get out to like the real story about it, it's like, okay, so what could I do that would make a maze that the elves have to explore? Like, well, it could be the first floor of a building with a weird security system, and okay, now instead of it being a grid, it's like hallways and conference rooms in a building, and those are the nouns we use, and whatever, right? Or every once in a while, because puzzles aren't the right difficulty, the beta testers get to it, and it turns out it's way too hard or way too easy. Sometimes I have to move it earlier or later in the month, and all of a sudden I have to rewrite all the prose because none of it makes sense in the story anymore, and you go back and do it. So while it seems like this is the flow, it's not. The flow is more like that. Just, you get there eventually, but you go round and round and round and figure it out. It's a bunch of stuff. So let's talk about, if that's clapping, am I late? Yeah, okay. So let's talk about, what time is it? 6 minutes, all right. So here's a couple example puzzles. I'll speed it up. Here's a couple example problems. This one is, how many square inches of fabric are within 2 or more claims? And it gives you a list of like, here are all the claims, here's the coordinates of these things, and you can draw a thing like this. And then it says, which one doesn't overlap with anything else. It's there. There it is. Or you have ones that are like, here's a history of all of the times a guard woke up and fall asleep and went on shift. Find the guard that has the most minutes of sleep, and of all guards, which one is frequently asleep on the same minute. Some people like to do data analysis, and so they'll build like giant diagrams and graphs and things like this, but other people really enjoy just building animations of the puzzle where every once in a while the guard, falls asleep for a second, and then wakes back up, and falls asleep again, because whatever, great. This is a puzzle I really like where it just lists out all of the places where there are walls, and it's trying to design a water reservoir where there are walls and the water will come in and flow down. And some people like to solve it by actually animating out the solution, which is super, super cool. I love this. Where you can kind of see like how the algorithm that they wrote behaves in different situations and how it fills in different parts and that sort of thing. Here's one that tries to define a maze by giving you a regular expression that matches the solution to the maze. And it's designed in such a way where if you try to actually run this as a regular expression, it will never finish. And the goal is to try to trick somebody into building a very simple regular expression like parser, because it's just letters and groups, so it's not that bad. But if you try to just like hand this thing random strings until you give it the answer, it will never, ever, ever finish. But if you try to like step through it and see what the steps are and backtrack when something needs to be backtracked, you instead get this visualization, which actually steps through the regex and figures out what the maze is shaped like, which is super cool. Or here's one that asks, what are all of the squares, or what squares are closest to which points? And you have to try to find the region of something, I forget. And then it says, all right, now take out all of the square, or all of the regions that are infinite. And you have to say, well, how do I know whether it's infinite? Like, how do I measure that? How do I detect it? What's the situation? Here's a cool one that's a cellular automata that ends up generating these really cool spirals just by random. I was screwing around with parameters for cellular automata, and I eventually found one where the random initial conditions typically produce just these cool random patterns. Like, okay, that has to be a puzzle now. That's required. Here's one where it gives you a bunch of points and their initial positions and velocities, and it says, where do they collide if you just run the simulation for a while? And so here's somebody that used GNU plot to just run all the points and to keep track of where they are, and all of a sudden they all fly in, and a bunch of them collide, and then a bunch of the rest of them just spew off to infinity. A lot of people like to use the time it takes to solve a puzzle as a metric for how hard it is, but I don't really like that because, like I said before, the people that are doing it right at midnight are all competitive programmers that do this all the time, and so the time that it takes for a competitive programmer to do it is not going to be the same amount of time as the time it takes you to do it. The competitive programmers are used to fancy data structures, fancy algorithms, skimming the problems a whole bunch, whereas most programmers aren't focusing on that stuff. They're thinking like, how do I build a solution that can handle problems of this category? How could I build some code that maybe I could maintain? Or maybe just, how can I stumble through Rust until the borrow checker stops yelling at me? But, you know, regardless of what it is, your time isn't going to match these exactly, but this does show that people roughly spend about, you know, less than an hour, at least the speed programmers, solving all the puzzles, which is good. And the ones that are up there, I'm sorry for, it's hard to calibrate difficulty. It's very difficult. So let's talk about some growing pains. No, wait. Let's talk about some learning experiences. They're the same thing. How do you prioritize tasks? I'm great at this. This is my strategy, all right? Thing happens. You handle the thing. Go to one. Easy. One thing at a time. Everything is top priority. How do you prioritize tasks if you have 250,000 users from all around the world of all different backgrounds? Okay, let's see how that worked. Thing happens. Great. Handle the thing. But while you were handling the thing, several other things happened, and when you try to handle those things, more things happen, and then you never sleep. This is bad. So you actually have to take a second to think about what's going on. Actually stop to prioritize things, which I'm not used to, but it's really important, obviously. It's okay to ask for help. A lot of people struggle with, like, being able to say out loud, like, I am having problems and need help with a thing that I'm struggling with, but that's an okay thing to say, and you should say it all the time because it's acceptable and fine, and you need help, and it's okay. Write better documentation so that users can ask you fewer questions because they already have the answers from somewhere that it's written down. Have an incredibly supportive community that helps itself. So the subreddit is full of people who, I don't know why, but are all extremely supportive, and if you come to them with a question like, hey, this is the code I wrote for this problem, it's getting the wrong answer. This is my input, this is what I'm getting, what's going on? And they never do they say, oh, you're dumb, you have a typo here. They'll say things like, try it with this input. What does your program do? Or like, step through the logic of your program when you give it one of these. Or have you thought about what happens in this situation? And just like try to ease people through it, which is incredible and really great, and everybody's teaching each other. And I'm really thankful for it. Also automating tasks and providing tools, both self-service and just for me. So if a user needs me to do some action to their account, manually going to the production database and typing in the query that does that is not a good strategy, surprisingly. You should instead build tools and have things just automatically occur whenever possible, because that's one less thing that you have to think about when things happen. You have to handle the thing and more things happen, as per steps 1 through 5. Also accessibility. Accessibility is pretty important, but accessibility becomes more important when you have 250,000 users looking at your site. Following the accessibility group's guidelines for things is really, really important. Carefully testing it, making sure that users of all different backgrounds and all different accessibility levels use your site and give you feedback, and taking that feedback very seriously is really, really important too. It's a critical thing to think about. Denial of service attacks is fascinating. First of all, why would you DOS a programming puzzle website? I don't know, but we get them. Fascinating. Fortunately, AWS will let you just say, don't allow requests from any of these IP ranges, and I'll just block like whole IP ranges for a while until they stop, because there's no other, I can't cope with it otherwise, there's no way. So I'll go through some frequently asked questions quick. What's time? Yeah, okay. I'm being told to very speed up, so. Why do they unlock at midnight, or why don't you make them unlock at a different time every day? Because I have a job and a family, and that's when I can be awake. I watch the servers, I make sure nothing's wrong. How long does it take to make 25 puzzles? About 4 months of all of my free time. Like, literally while I was here, I was sitting in my hotel room building puzzles. Like, the past few months, I've just been like, I go to work, I come home, I build puzzles. Like, it takes forever. Can I send you puzzle ideas? Please don't send me puzzle ideas. I have so many puzzle ideas already. I have a giant document with hundreds of puzzle ideas. If it looks like your email has a puzzle idea in it, I will reply back. I did not read your email. It looks like a puzzle idea. If I made a mistake, please let me know. But I don't want to deal with copyright issues. I don't know where you got the stuff from. I can't confirm that you didn't like grab it from some other website. I don't want to deal with attribution. Like it's okay. I have lots of puzzle ideas. That's not something I'm struggling with. Please don't send me them. Why is the site rejecting my answer? Probably because you were one of the people that skipped a sentence that was important today. Or because you have some kind of a weird bug. In any case, ask on the subreddit or ask your friends or something. People are typically very helpful. Does the site lock after getting a wrong answer? Or occasionally, why do I have to wait an hour to submit my next guess? The site does lock after a wrong answer. It locks for 60 seconds. If it thinks you're spamming guesses, it will make you wait longer, because don't spam guesses at the website, please. If you see somebody on the subreddit or on Twitter saying, like, I can't believe I have to wait an hour between guesses from it, they just submitted 100 guesses, got them all wrong, and they're complaining now that they can't submit more. That's what that is. How do some people solve the puzzle so quickly? Or are people cheating? No, they're just very, very fast. They do this basically all the time. The way that they do it is they open the input, they look at what the input looks like, because the input's all that matters ultimately. They guess at what the puzzle is. They read the last line of the prose to see if their guess was right, and if it wasn't, they confirm by just looking back up a little bit. Then, before reading anything, they build a solution. And then as they're building it, they go back through the prose, like as they're reading it somehow, I don't know, and then they figure. People post videos of themselves doing this, like live at midnight, and that's really what they do, and it's nuts. They're not cheating, they're really solving it that fast. Is today your birthday? Yes, today is my birthday. Thank you so much for asking. And I'm going to end with some quick stories that I just really like because they're ridiculous. So here's one that I like. As the non-participating mother of a 14-year-old that got up at 4:50 a.m., I'm both massively impressed that people do this and somewhat baffled that nothing else has this effect. I've been reading here so I can make sense of the conversation later in the day. So this is the mother of a 14-year-old, where during the day the 14-year-old just wants to talk about this programming puzzle that they've been working on, and the mother's like, what words are you using? And then has to go to the subreddit to figure out what they're even talking about so they can actually have a conversation with their 14-year-old during December. Or here's somebody that says that they helped them get a new job, or I get some that say, like, this helped my significant other, like, we went through these and helped them with interviewing or whatever. There's a bunch of these like this, which is so cool. Or my son and daughter are becoming more interested in coding because of your site, which is fantastic. Or I got a message once that said something like, I haven't had a good relationship with my daughter, but after she started seeing me do Advent of Code, she's been asking me to do it with her, and I've rebuilt that relationship. Like, it's just completely ridiculous. Here's a college course that used Advent of Code as a midterm. And as the final. In conclusion, engineers in an organization should solve puzzles for fun. In fact, everyone should solve puzzles for fun. Thank you.